Hi everyone, I'm Dan. So firstly I just want to say thanks to Neo4j and ThoughtWorks for organising this event. Great team over here putting it all together, so thank you to everybody. So let's get started. So I'm from London, you can probably tell by my accent, and I have a company called rconnect. You can find us at rconnect.tech, and we're a software consultancy and we build APIs and open source libraries. As I mentioned, I like tea. I also like coffee, but I'm from UK, so I do like tea, and I'm from these lands. And I walked here as well, so if you're interested in my long walk, then come and talk to me after this. I'm just kidding, I didn't walk. So I do code a lot, I travel a lot, do a lot of meetups, but I was part of the Neo4j GraphQL team, which is what I'm going to be talking to you about today. And also there's tools like Prisma, if anybody's heard of that. I was also a core contributor to Prisma, the ORM. And then various GraphQL things, GraphQL meetups, GraphQL open source. And we have a solution called GraphQL Debugger as well, which I'll show you at the end of this talk. Just a little bit about me as well, that I've started a YouTube channel with this camera that's also filming this event. So I was actually in ISKCON Temple, Covent Park, the Bangalore Palace and the market yesterday, so I put that on YouTube, so you can go and check that out if you're interested. And then some stuff of Bali, and I'm sure there'll be some more stuff coming, but I need some more subscribers, so if anybody can subscribe, please do. Thank you. Enough about me, the agenda of this talk. So we're going to go over a little bit about what is GraphQL. Who's using GraphQL or heard of GraphQL before? 1, 2, 3, 4, 5. Okay, so not too many of you, so you're in good hands. Then we're going to show you how to get started with GraphQL and then mix it together with Neo4j, with their Neo4j GraphQL library. So what is it? So you might have seen the logo around. It's an organization. You can go to graphql.org. But to understand what GraphQL is, you first have to go back in time and look at Facebook Mobile in 2011. Facebook were pioneer the space at the time. They had a lot of users, and also mobile applications started to emerge, and they looked like this. Basically, they looked terrible, and it was basically a web view, a HTML5 view rendered on a mobile app. And this was terrible for performance because it meant that the mobile app was basically reading all of the same APIs that the desktop was. And these mobiles were 3G or 2G, and the network signal was nowhere near as strong. So they started, constructing their APIs at Facebook to fit the needs of their clients. So they had the desktop client, and this talks to the API that queries the database. And they would have some URLs like the posts with the images or the desktop view or something like that. But then as mobile applications started to become more prominent, they started finding themselves molding the APIs to fit the needs of the clients. So you see down the bottom here, you've got like the posts without the images, because maybe you don't want to display the images on a mobile. And then you've got like the iOS dashboard, the Android dashboard, and their APIs started to become really messy. So they was basically asking themselves this question of like, where's the person who's using REST correctly? Because they had this API with loads of routes, nobody knew, it wasn't schemaed, it wasn't typed or anything like that. So they came into a bit of a problem. This is where they invented GraphQL. So instead of thinking about your data as tables and columns and endpoints and URLs, what about if instead you just thought of your data as a graph? And this is much more instinctive when you're thinking about your data. You can draw your data on a board as a graph model. And so this is how GraphQL came about, and this is what GraphQL is. And so if you go to graphql.org, you'll see these 3 points on the home page about describing your data, ask for what you want, and get predictable results. And they do this via two things, and it's the query language and the runtime that GraphQL comes with. So the first point is describing your data. So most REST APIs nowadays have OpenAPI, where you can have a schema on top of it. But back in 2011, this wasn't the case. And so they had to come up with a schema language for your API. And it's quite straightforward. And if you're used to most programming languages, you'll be able to understand it. Basically, we have users of our API. And then we also have some posts of our API. And then this next type that I'm going to show you is like a special type. It's called the query type in GraphQL. And this is essentially the functions that you can call on your API. So think of the user's query and the post query as get endpoints on your REST API that return a list of users or posts. So this is the schema definition language of GraphQL. And then the other side of that is the runtime. So once you've defined your schema, and I have two functions essentially I can call on my API, I'll then back them with what's called resolvers. And here, just a contrived example that the users basically just get all of the users from the database and the post query does the same. And the GraphQL language is split into two parts. So you have the schema definition language, which is what I just showed you. And then you also have the query language. And you can see here that we're asking for user's name and location. And then what that will do for you, the runtime will resolve that into a structure that looks very similar to your query. So this is asking for what you want. And then we have something called get predictable results. So we circle back to 2011 at Facebook when they started introducing endpoints for iOS, Android without the images. They solved this problem with the GraphQL query language by allowing you to only select what you're looking for, and the client will only receive that. So here I'm asking for user's name and location, but I can, for example, ask for a relationship and get that data back as well. So if we just circle back one slide, you'll see that the user's name and location only returns the data that the clients ask for. And then if I add a relationship into there and query that, then the GraphQL runtime is going to resolve that for me and return exactly the data that I asked for. And this solved the problem of Facebook Mobile because it meant that each client can talk to the exact same API, but the client just changes its query depending on what it's looking for. And I'll show you a demo of that. So I'm predominantly a Node.js guy. So who here use Node or TypeScript or JS or anything? Or okay, I'll try and keep the code very straightforward. So here we have. Go. Dismiss it all. So what we've done here is we've used the GraphQL schema definition language to define our schema. So we've said that we have movies and that there's a function on our API called movies that returns a list of movies, and they're not null with the exclamation mark. Then the runtime part is that you define these resolvers. So you see here that I've defined a JavaScript function that returns a static array of movies to fit the shape of my schema that I just defined. And then what you can do is you can just use some like off-the-shelf solutions to start your server, essentially like using Express or something like that. And then you'll get this server started for you. So let me run it. There we go. So it's taken me to what's called Apollo Studio. And it's basically like you can think of it like a SQL workbench, but for GraphQL APIs. And it's going to allow me to, in development, to query this API and see the results. So because we've only defined a movie and it has one field on it, which is title, and we only have one query as well, we can only query for that at the moment. So we can ask for the movies and the title, and then that's going to return that for us. If you want to extend the API, for example, movies also have released, and that's an integer. You can stop and start that. I will also return released. And I'll come back here, refresh that. So I can ask for just the movies and title, and the runtime's just going to return that for me. However, if maybe I have a desktop application or something that can show more information, then that client can simply ask for that data and then it will just get that back. And this is resolved at runtime on the server, so the client's not doing any filtering, which really saves on network costs as well, because if I ask for just the title, then the title's only going to get returned over the network, which is saving a lot of time, compounded over time as well. So that's like a brief primer to GraphQL. Does anybody have any questions? Yeah, go ahead.
I'll just talk about some of the areas where I'm using Graph as a database and trying to query things. So I'll give you a scenario and maybe you're the expert. Talk about where does the graph give the picture. So today say I have a graph database hosted in infrastructure. And that is one of the services that I'm using.
Yep.
On the other side, my application is mostly based on Python. Right? Now, in order to define all the data types or say the schema that you're talking about, what I basically do, I define the data type in Python, which is very specific to my business application. Right? And same has also been converted in the form of schema in the GraphQL. Right? And in between, I use Cypher query to pull whatever I want to, pull from the database or GraphQL using some sort of query. Now, in my setup, there are three independent components: GraphQL, Cypher query is the query language, and I have a tight collaboration between Cypher and how those return data is being converted to a Python object. Now, in this whole ecosystem, where do you see GraphQL comes into picture and how some of these can be maybe?
Sure. So you could, for example, I will going to show you the Neo4j GraphQL library in a second as well, which is going to answer a lot of your problems. But because GraphQL it has a schema, you can convert, for example, your Python models into a GraphQL schema, and then you can leverage the Neo4j GraphQL library that will generate the Cypher queries for you. But I think my next slides are going to answer your question a lot more because I haven't gone into the Neo4j part yet, just an introduction to GraphQL. I'll continue, and if you have the same question, please shout out.
Yeah.
Okay, so that was a primer to GraphQL. Let me show you now in Node how to interact with our database. By the way, we have a database running. It's running here, a Neo4j desktop, and I've just spawned in the movie graph. So we have a bunch of movies in our database. So with the driver in Node.js, we can basically, spawn a driver and then issue a query, matching the movie and projecting out a JSON object of the ID and title, and we'll get like a list of records back. So most of you who don't know about the Neo4j GraphQL library, what you'd probably do is, take this driver, come to our GraphQL API, put this there, and then maybe grab all of this. And instead of returning the hard code data, what we maybe do is something like that. So now, we're asking for the movies. Oh, we also need to add the released, like that. So that would be like a hard-coded GraphQL API. And I think if I run that, hopefully the demo gods are watching us. Is it already running? If I run that now and ask for all the movies, okay, I think there's some like parsing that I need to do for the raw results from the database. Let me have a look and see what the console is. Sure. No problem. Oh, too. No problem. Let me try that again. Node resolvers. Run that. All come out as null. But you'll see that basically reading raw from Neo4j using the driver, we get something that looks like this. So it's quite difficult to pass this back into the shape that GraphQL looks like. You see it has like native integer types, the strings have like padding around them and stuff like that. So if you're reading raw from the database, you'd have to manually pass each one of these values. And so this is where the Neo4j GraphQL library comes into play. One, you don't have to write Cypher, and two, all of the values are passed for you. I'll show you the intro slide. So they have open source library, Neo4j GraphQL. you're in good hands, as I was the first contributor to this library, and it's open source, so go give them a star and check them out. It's running on Node.js, so you need a Node.js runtime to get started. But in a second, I'll show you an API with about 40 lines of code backed by Neo4j, so you don't even really need to know Node to get started. So let's go to the example. So here we go. So as spoke about at the beginning of this talk, we have the schema definition language of GraphQL. So the Neo4j GraphQL library leverages this, and this is basically your database schema in your application layer. So we're saying that the type movie is corresponding to a movie, a node with the label of movie, and then the title is a string, and that's a property on that node. Then what we do is, we construct a driver that could be anywhere pointing to anywhere, and then the real magic really happens on this highlighted line here. We basically pass the type definitions, the schema definition language, into the Neo4j GraphQL engine, and then it gives us like a GraphQL schema, and we can start that with some boilerplate code underneath here that I won't bore you with. So the only input really to Neo4j GraphQL is these type defs. And I'll start my server. Okay, so this is a different server, so I haven't added released in there. But now let me just run the movies query. And now you'll see that it's actually fetched the movies from the database and passed all the results into something that's useful to me. And what I'll do is I'll run debug mode. I don't know why it gets locked in like that. Debug star. So debug star is basically just going to print out everything to the console, and we're going to be able to see the generated query from the library. Run the query again, and you'll see somewhere in here that Neo4j GraphQL execution, basically it matched a movie and then projected the title out of that movie, and then the engine done some passing on the string to make it readable to consumers. But it doesn't stop here, because we've got other properties, we've got relationships in our graph, and I've only defined a type movie. So what I'm going to do is just use this backup type defs that I stored. Copy it in here. Formatting does not seem to be working, but I'll format it for you. Okay, here we go. So here's a more real-world example of how you would use Neo4j GraphQL on top of Neo4j. So what we've done is we've added a few more properties like released and name, and we've also introduced a new node called person. But the real value is actually using this annotation here. So this is called a GraphQL directive, and you can put it on a field or a type. And so what we're basically saying on this highlighted line is that movies have actors, they're of type person, and the relationship between them is going to be acted in. And then you can define the direction as well. We're just saying that people act in movies, that just depends on your data model. And then we've also defined it the other side as well. So this will generate a GraphQL API for us that we can traverse basically cyclically if we want to. We can obviously stop that from happening. So let's start this server. Refresh that. So of course now we should be able to ask for a title and released, and we get all of the stuff back. And you'll see in the console, wherever it is, that this time it projected the release and the title. So it's taking the GraphQL query and reflecting that into a Cypher statement as efficient as possible for you. So if you only ask for the title in GraphQL layer, it's only going to return the title from the database for you as well. But because we've added these lines now, these relationships, we can also traverse them. And so the engine's given us a couple of fields on the generated API like actors. So I can ask for all of the actors of every movie, or all of the movies, and then all of the actors inside all of those movies, and the name of those actors. And here you can run that, and then what it's done is it's generated the most efficient Cypher query for you, traversed that relationship, and then sent that straight back through the GraphQL layer. And let's have a look at the generated query. Where is it? So the generated query will look a bit different this time. Here it's highlighted. So this time, because we traversed the relationship, it's doing a subquery, traversing that relationship based off of the directive that we gave it in the GraphQL schema, and then giving it back to the engine, and then the engine does some like mapping on it to make it look like a JSON structure, which is easy to use for your application layer. This API that's been generated doesn't just do reads. So given the input that we gave it of type definitions, you also have a bunch of other CRUD-like methods that you can call on this API. So there's many queries, there's aggregations, there's filtering, and I'll show you an example of filtering. So the matrix, for example. So find me all the movies. Oh, let me turn this option off. Where, it does that all the time, where the title contains matrix. And there's a couple of matrices in what's gone wrong with the query. Hang on. There's something wrong with that? Oh, it's title. There you go. So it's also given us like a bunch of filters like contains, regex, you can do like greater than, less than, all of the basic. Go ahead.
So if I have to compare between using GraphQL to retrieve any nodes versus directly writing the Cypher query, is there any additional latency overhead if I go for GraphQL?
Could you say your question again? Sorry, I couldn't quite hear you.
So basically, I could have two options. I can manage to write Cypher query by myself.
Yes.
As I already have understanding of the schema
For sure.
from
Yeah.
the business definition, or I can use GraphQL to do the query, right? So if I have to compare these two in terms of latency, is there any additional latency overhead if I go for GraphQL?
There's definitely going to be latency if you add this library because it's generating queries for you. So GraphQL, the query that's coming into your server, that first has to get passed into an AST. So depending on the size of your query, that could be quite complex. Then the engine has to traverse that AST and generate a Cypher query for you. So there's definitely going to be latency. But with this library, the team go for developer experience over performance. Most people probably don't need the most performant application, depending on what you're doing. But we always say that if you're using this library and you care about performance that much, then just write the query yourself.
But there is also the fact that when I'm writing the Cypher query by myself, maybe I'm not the expert and the way I'm writing the query might not be the optimal one. But can I expect maybe the way GraphQL will be generating that query maybe a lot more optimized in terms of whenever there is a very complex queries?
So the queries that are generated from the Neo4j GraphQL library are built by GraphQL engineers, not database engineers. So that may answer your question for you.
The other question, is it only useful for retrieval, or is it also useful to build the graph itself, like inserting nodes and relations?
Yeah, I'll show you a mutation if you'd like. So so I've showed you a bunch of queries, but with GraphQL you also have a special type called mutation, and these are inserts basically or edits. And so if we just come up with create a new movie, there we go, create movies, and the title, Dan's Cool Movie. What is it? Data, movies, title. Let me format that as well. So that will basically just do like create node with the label of movie and a property Dan's Cool Movie. But one of the benefits of using Neo4j GraphQL is that it has something called nested mutations, which is essentially inside this JSON structure, I can input the related nodes and the relationships at the same time, and it's going to build that graph for me. So for example, the movie is Dan's Cool Movie, and the actors, I'm going to create an actor. I'll format that. I'm going to create a node with the name of Dan. Let me format that. Oh, there you go. So this would basically do like a create movie line to person and also create the person at the same time. I can insert that. And if we have a look at the generate query, what is it? You'll see that it's done this. And so this is, to your point about efficiency, here, for that create statement, it generated this. So it's machine generated code, basically. So you don't really want to use it if you're really desperately in need of performance, but you do get a lot of these benefits from it. You know, you can insert data in like a JSON-like way. You get all the benefits of GraphQL, and it's also really quick to get started. So that's kind of like GraphQL intro, Neo4j driver info, Neo4j GraphQL intro, queries and mutations. Does anybody have any questions? Sadiq?
In the Neo4j graph itself, right? So it has its own schema. So the model would pick up the schema and it would understand the schema by itself. Whereas the database, if the graph you're doing mutations right from that you're building, right?
Yep.
Pushing it from the Node.js app.
Yep.
What if I can do mutation externally on the DB? Would the model automatically understand the fields?
You mean if I inserted data directly into the DB outside of the GraphQL API? Yeah, so as long as the API matches the schema, so Neo4j doesn't have a schema. So Neo4j GraphQL tries to put a schema on top of the database via the GraphQL API. So I can go ahead, for example, like a movie. So for example, create a movie, and it has a title, Dan's Another Cool Movie. And what we'll do is we'll add like a property, because it's no schema, we'll add a property that's not defined here, like, I know test, 1, 2, 3. And let's get that. So Dan's Another Cool Movie is in the database, and it's got like a random property on it that's not defined here. I can query for that movie. So query movies title. It's going to return that through the GraphQL API. But of course, I can't ask for the test property because it doesn't exist in the GraphQL schema. But I can just add it, and it will just pass it through. So I can just come here and be like, test is a string, restart the database, and then run that again, and then it will sort of propagate it through. But of course, you have to be careful inserting extra data, because of course, some of them are going to be null. Depending, if it's not going through Neo4j GraphQL, then it's not type checked or it's not validated. So you just have to trust that external data coming into the database.
So the values of the fields should be in the graph for Neo4j for us to fetch.
Yeah.
But if it's external, it has to be somehow mutated either by the application or externally within Neo4j.
To fit the schema that you've got. Yeah, yeah.
We can add
you can add constraints and everything in your project.
Okay.
Like you can have a constraints like you can like this is the field is required.
So there is some amount of variation
Within
within the
but by default we are following the schemaless,
right.
but you can add your own constraints, your own instances, depending upon it.
Right.
They also have this one thing in the Neo4j GraphQL library. I'm not exactly sure what it is, but they have a bunch of these directives, the GraphQL directives the library picks up, and one of them, I don't know the exact name, but you can like alias it. Is that how you spell alias? Yeah, something like that. And then it will basically map that in the GraphQL layer for you. So if you have external data that's, adding a underscore in or something, then you can map it back through the GraphQL API and it will propagate it out. Does anybody have any questions? Okay, cool. And I'll show you one other query as well. So there's also aggregations this library generates for you, which is super handy. So for example, I can count all of the movies in my database and that'll give me 40. And then I think I can also can I do any more? What's on this type? I can't remember how to, my keyboard not broke, but I used to be able to do command space and then it would show me all of the options, and now I just don't know, so I don't know what options are available. Title, longest title. There we go, let's see what happens. Title? Longest? There we go. So it has like cool aggregations in there as well to find the movie with the longest title. And interestingly, what would be the query that it generates? Here. So it matches the movie and then uses some of Cypher's string functions to return the longest title, which is super cool. And these aggregations can get quite nested. You can do like a relationship aggregation, like find me a movie and then find me all of the count of the actors or something like that, which is quite complex. Okay, so I think I'll end that one there with Neo4j GraphQL. So you can go to github.com/Neo4j GraphQL, give them a star, try them out. It's about 40 lines of code to get started. In fact, how many lines of code was that? Okay, give or take 43 lines of code to get a fully functional GraphQL API backed by Neo4j, aggregations, mutations. It has authentication built into it as well, so you can go to production with this. And other features as well, like there's an ORM, so you can basically put your type definitions in the ORM, and then it will give you like a Prisma-like model that you get all the same API, which is really handy as well. Because sometimes you don't want to expose your whole GraphQL API to the public, so by using their ORM, you can kind of conceal it in a way behind your own routes. So that's enough about Neo4j GraphQL. As I said, rconnect, we're a consultancy. I travel around a lot, do a lot of these events, and also foster open source work. So we bought a bunch of domains like graphqldebugger.com, graphqlai.com, so you can go and check out those projects. Domain names are both for sale as well, so if you want any of them, then hit me up. 1 Bitcoin for the AI one. And that's it from me, so thank you very much for listening, everyone.